The search for oil has taken us to some of the deepest parts of the ocean. Today's oil rigs, also known as offshore platforms, can drill over 10,000 feet below the surface, with some rigs reaching even greater depths. These feats of engineering require cutting-edge technology and the expertise of some of the world's most skilled workers. In this video, we'll take you on a journey to explore the construction of the world's deepest oil rigs. So, without further ado, let's get started. Oil rigs are massive structures designed to extract oil and gas from oceanic depths. Built to withstand the harshest environmental conditions, including extreme weather, powerful waves, and strong currents, these rigs are a marvel of modern engineering. Design. Building deep-water oil rigs requires years of planning, design, and construction to create structures that can endure the severe conditions of the ocean floor. During the design phase, engineers and designers work together to create plans for the rig's structure, size, shape, and features. Each design is customized based on environmental factors specific to the intended drilling location, such as water depth, currents, and wave height. With waves that can tower over 100 feet, these platforms must be designed to flex and adapt to such forces to maintain stability. Engineers also consider the type of oil and gas reserves that will be extracted, as this affects the type of drilling equipment needed. Additional safety systems are integrated into the design to ensure that the platform remains secure, even under emergency conditions. To streamline the design process, engineers use advanced computer-aided design CAD software to create 3D models of the rig. These models allow them to simulate different conditions, testing how the rig might respond to extreme environments. Engineers can make adjustments as needed, helping ensure the final product is safe and functional for long-term use. Fun fact, the average deep-water oil rig weighs approximately 30,000 tons, which is equivalent to the weight of 100 Boeing 747 airplanes. Fabrication. Once the design phase concludes, fabrication begins. During this stage, various components of the rig, such as the drilling platform, subsea systems, and living quarters, are constructed. Typically, these components are built in different locations, each site specializing in certain parts. For example, some facilities focus solely on subsea systems, while others are dedicated to constructing the platform's structural support. The fabrication process requires specialized expertise. Each component is manufactured in facilities equipped with advanced technologies and materials, capable of withstanding harsh offshore conditions, such as saltwater corrosion and high-pressure environments. Structural materials are carefully chosen for durability and resilience, with many parts made from reinforced steel to provide maximum strength. After fabrication, these components are then transported to the final assembly site, usually on shore. Assembly on shore helps ensure each component fits together precisely before the offshore installation. Transit. After fabrication, the completed components need to be transported to the offshore site. Transporting an oil rig is no small feat, as these rigs are among the heaviest and largest moving structures ever created. This phase involves a specialized fleet of ships and vessels that carefully maneuver the rig across some of the world's most challenging waters. Transporting a rig can take several months and requires extensive planning. Components are loaded onto transport vessels using cranes and other lifting equipment, then carefully secured to prevent damage during transit. These vessels, known as heavy lift ships, are specially designed to carry massive loads and can transport components that weigh thousands of tons. The vessels themselves often include living quarters and kitchens to support workers, making life at sea more comfortable. Upon reaching the offshore site, each component is unloaded and positioned in a secure location, ready for assembly. Fun fact, some of the largest oil rigs in the world require over 1 million man-hours to construct, which is roughly equivalent to 500 years of work for one person. Installation. Once all components arrive at the offshore location, the installation phase begins. During this phase, workers assemble the rig's various parts, from the drilling platform to subsea components. The installation process is time-intensive and can take several months to complete. Each component must be precisely positioned and secured using cranes, welding equipment, and other specialized tools. The installation phase is critical to ensuring the rig's safety and functionality. Each part is thoroughly checked, welded, and secured, and the installation team works under challenging conditions, often facing strong winds, turbulent seas, and extreme temperatures. Installing the subsea systems requires divers and remotely operated vehicles, ROVs, to attach key components underwater. This equipment allows the rig to safely extract and transport oil and gas from the ocean floor to the surface. Commissioning. After installation is complete, the commissioning phase begins. This phase is crucial as it involves a series of rigorous tests and inspections to ensure the rig is fully operational and ready to drill for oil and gas. Testing includes pressure tests, flow tests, and electrical checks, with results analyzed by engineers to ensure all systems work as designed. If any issues arise during commissioning, they are addressed before full operations begin. The commissioning team makes any necessary adjustments to ensure the rig meets safety and environmental regulations. This phase also includes training sessions, where workers familiarize themselves with emergency protocols and procedures specific to the rig's unique environment. Drilling. With the rig fully operational, drilling commences. Deep water drilling is one of the most complex and technologically demanding parts of offshore oil extraction. Drilling equipment is designed to penetrate thousands of feet below the ocean floor, withstanding intense pressures and temperatures. Key technologies include the blowout preventer, BOP, a large valve that can shut off oil flow in case of an emergency. The BOP sits on the ocean floor and is essential for maintaining safety, especially in deep water drilling. The BOP prevents uncontrolled oil spills, which can be catastrophic for the environment and marine life. Another crucial system is the riser, which consists of pipes connecting the drilling rig to the ocean floor. The riser system enables the rig to move with the waves while maintaining a steady connection to the well. This flexibility is critical, as it prevents damage to the equipment during rough seas. Fun fact, some drill bits used in deep-sea drilling can operate at temperatures exceeding 300 degrees Fahrenheit, an environment where conventional materials would fail. Risks and safety. Despite the advanced technology and engineering involved, deep-water oil drilling presents significant risks. One of the most prominent examples of this risk is the 2010 Deepwater Horizon disaster in the Gulf of Mexico, where a blowout led to a massive oil spill. The incident caused devastating environmental and economic impacts, resulting in the loss of marine life, the contamination of local ecosystems, and billions of dollars in cleanup costs. The future of offshore drilling. The construction of offshore oil platforms is a monumental endeavor, requiring exceptional expertise and planning. From the design phase to commissioning, each stage of the construction process is critical in ensuring that the rig remains safe and functional. Engineers and construction crews have developed numerous innovative technologies and techniques to overcome the unique challenges of deep-sea drilling, making these oil rigs some of the most impressive structures in the world. Thank you for joining us on this deep dive into the world of offshore oil rigs. We hope you've enjoyed learning about the impressive engineering and construction efforts behind these massive structures. If you found this video informative, please give it a thumbs up, share it with friends, and don't forget to subscribe for more content like this.